Let's get started with NumPy. As usual, we're going to start by importing the library. There's a sort of a standard alias, which is NP, and it's quite convenient to have a short alias because we're going to be typing that quite a lot. We'll import matplotlib again, and we can have a look at the version using numpy.version. In this case, the version that CoCalc is running. We're also going to make a lot of use of the manual. NumPy's got quite a good manual, I would say a better documentation than Python itself. If we look at the API reference, for instance, we can go to array creation routines, and it gives us a nice list of various ways that we can create arrays. So we'll have a look at a couple of those now and draw on other ones as we need them during the course. As usual, there's many methods available, and we're not going to go through them one at a time. We're just going to draw on them as we need them. But we'll just look at a few to get us started. So firstly, so we saw there one way is using ones. That's this one here. Okay, and that'll create an array of ones. And notice here that the arguments are an int or a sequence of ints. Okay, so the argument, if it's a 2 by 3 array that we want, it has to be in brackets as a tuple. We're just going to start with 1D arrays. But the other thing I just wanted to point out was that the default is a float. Okay, so here we're going to create an array of ones. It's just a one-dimensional array, so we only need one number. So 10 tells us that it's going to be 10 items long. Now the other one that's very useful, and we'll see it a lot, is this kind of zeros like or ones like format. Let's just have a look at zeros like. So this tells us that it returns an array of zeros with the same shape and type as the given array. And we'll use that quite a lot when we want to generate another array that's the same size and type as one we've already got. So let's just run that one, and generates an array of 10 ones, and the second one, zeros like this one, it generates an array of 10 zeros. And you can see there the decimal points, which shows you that those are floats. And as I said, that's the default. If we don't want floats, if we actually want integers, then we can explicitly do that, ask it by putting in D type or data type. You'll see this again in a lot of different methods where we want to specify what type we want more specifically. So in this case, we can say we want it to be ints. Now, zeros like, as we said, copies the shape and the type. So that will also give us floats for the zeros. So if we just run that, we've got our array of ones, this time as ints and zeros. Another way of getting arrays is to generate them from lists. It's a little bit like casting them. And again, we'll see this quite often, casting back and forth between arrays and lists. And when we look at other kinds of tables of data, we'll also do that as well. So here we've got a list 1, 2, 3, and we're just passing that to the constructor. numpy.array is the constructor for arrays within that numpy library. And you can see it's created an array 1, 2, 3. They're integers here, so they're integers here as well. Notice you get something different if you print the array, which gives you this, or if you just leave spylof then just to evaluate the array, in which case it tells you that it is an array containing 1, 2, 3. So whenever we see this is sort of a nice shorthand, but it's really an array object containing those things. So selection and a little revision, because the selection methods are the same methods you've seen before using lists. So we'll just run through a few examples. So I've got one here which is a list, and I've got one here which is an array, and we'll look at the similarities, and we'll look at some differences. So the first one is just getting out item 2. Arrays like lists number from 0. So item 2 is 0, 1, 2. So it's the number 3 or the letter C there. We can do the same kind of slicing operations. So we can get from 1 through to 3. Now remember that just like with lists, our slice intervals are always what we call closed on the left and open on the right. That terminology comes from maths. When we use an interval like this, we mean that the 1 is included in the interval. The square bracket there means inclusive of that one, or closed. This one means the round bracket parenthesis means open at that end, or doesn't include the 3. So it's the same here for lists and arrays. So we start from 1, so that's position 0, 1, so we get the 2. And then we've got position 2, position 3, but the 4 here, which is at position 3, is not included. We just get 2, 3. Some other kinds of slicing shorthand. So if we just have the colon on its own, that means the whole thing. So here we've got the whole thing, A to E or 1 to 5 for the array. If we have 3 colon nothing on the right, that means from 3 onwards to the end. Okay, so remembering that it starts numbering from 0, so position 3 contains that 4. So we've got 4 onwards, or D onwards for the list. -1 allows us to number from the other end, from the right hand end. So that gives us the last item, which is an E or a 5. And a colon -1 gives us everything from the left up to -1, which in this case gives us A to D or 1 to 4. Why isn't the last one there, the E or the 5? Because remember that it's open-ended on the right hand side, so -1 is not included. It's easy to get kind of caught out by that, because when we specifically index -1, we're getting that last item, but when we use it as the right hand end of the array, it doesn't include that last item. There's reasons why it's been done that way. It's not just to be confusing. For example, if you're concatenating arrays or lists together, and you want to go to up to a certain number and the next one starts from that same number, that means that you won't get two copies of the item at that number. You'll only get a copy with the second list and not a copy with the first list. So when we start putting arrays together, it makes sense, but just something to watch out for. We can have a stride. So we saw this, we've seen a couple of examples of this in our ABS data, where we wanted to pick out the person data, where we got every third one, and also where we wanted to pick out we had the groups of 8 age ranges, and we wanted to look at the number of births for each age range, and so we picked out every 8th one. So we did that with the lists. We can do the same here with arrays. In this case, here we're picking out every second one from 0 through to 5. Remembering that 5, the array starts numbering from 0. So 0, 1, 2, 3, 4 gives us the last item in that list or array, so that E or 5 is included. And we've got every second one. This one here will give us everything, and give us every second one of everything. So that's looks the same as the previous example. This one here will give us every third one of everything, and I included this as an example because it just demonstrates what happens at the end of the list or the end of the array. And again, we saw an example of this in our ABS data when we're getting every 8th one, for example, that the end of the list just gets sort of left off or chopped off as you'd expect it to be. So here, every third one gives us 1, it gives us 4, and although the list goes a bit further, it doesn't go for 3 more, so they just get left out, as you'd intuitively expect. And one here where we're using 1 and -1, so this gives us every third one of the list without the 2 ends. Okay, so because the list starts from 0, 1 is the second item, and because the slice is open on the right hand side, it doesn't include the -1th element, so it's 1 off the right, and that means that there's only from here to here, every third one is this one, and then the next one is off the end of that shortened list, so we just get one thing back there. We've seen ranges a lot in Python. We use them a lot in our iterators. Arrays have a similar construct called arrange. Again, not to be confused, so it's got a slightly different name. Range, we know range, again, you can have a start and an end, and you can have a step. In this case, we've just got the end, so that just defaults from 0 to 4. And if we print those, we get from 0 to 3. Of course, the 4 is the open on the right. So that gives us 0 to 3. We can do exactly the same thing with NumPy's A range, and if we print that, we get the same thing. So those two things, they've got similar names, and in some cases they do the same thing, but are they the same? Well, in fact, they're not. They're not actually the same. And one way we can see that is, I talked in the previous section about the fact that arrays are more efficient, have more efficient storage than lists, because you can stack them more efficiently in memory. So let's just have a look at that. And one way we can get the amount of memory used is by importing sys, that's short for the system, like the operating system, and that has a method that allows you to get the size of an object. So here we've defined a Python range from 0 to 50, and a NumPy range 0 to 50, and if we compare those, we see that Py range here has size 48 bytes, whereas NumPy range has 496 bytes. So that's kind of the opposite to what we expect, from the fact that we expect our NumPy range to be more arrays to be more efficient. So what's actually happening there? Well, we can see if we print the type that they're actually two, although they're used in the same way here, they're two different things. So the range in Python actually gives you a range object, whereas the arrange, that should be, sorry, no, that's what I called it, NumPy range. So the NumPy range will give us an actual array, and that's why this one here is bigger. This type range, the range object, is actually an iterable. So when we call it in a for loop, it actually generates an iterator on that iterable, and that's kind of hidden from us. So as it goes through them, it prints them out. We can do that more explicitly by using list. Again, we've seen that before. So that generates a list from that iterable, or you can think of it as sort of casting it to a list if you like. We can see that once we do that, list of our Python range gives us an actual list with all the items in it, and if we print the type of that, it's a class list. And if we now compare the sizes, we see that the NumPy array has size 496, and the Python, the list generated from the Python range has size 560. So that's what we'd expect. So we're comparing this one here to this one here, and the array uses less storage. In this case, it's not a huge difference, but it's just to demonstrate that difference.